It's a particular pleasure to be here today, and I would like to thank Michael and all the organization of the Space Generation Congress to have me here. I would like to take this opportunity to congratulate the SGC for its 10th birthday, 10th anniversary. This is a great event, and I see that you take the proper steps to celebrate it. And I see that it actually works out. By the way, the IAF apparently is a generation or two older. This year we are celebrating our 60th anniversary, so you know, there's still a good contact, but we see that there's a slight difference in the age. And this is really appreciated to have you here. You know, it was just mentioned by Michael that next week we have the IAC, the International Astronautical Congress, here. And it's, of course, not just a coincidence that you're here at the same place, nearly the same time. And I'm really looking forward to see a lot of you over there at the IAC. I also noticed I'm now following the activities here in the SGC for 3 years, for the time that I'm acting as president of the IAF. I see the progress, I see the numbers of audience increasing, I see the quality of presentations increasing. But I also noticed that my speaking time has been cut, and okay, we'll take consequences. Now, what I will talk about is the future. Of course, the next steps. This is probably what is most interesting for you. But to start off, I want to go a few steps back. We now have 50 years of space activities since Sputnik, and a lot of things has happened. We had the age of the early pioneers like Tsiolkovsky, Orbit, Goddard. You see Goddard here with the first model of a liquid-fueled rocket. Von Braun, I mean, those are heroes of space. There's triumphs for humanity that have been achieved, and of course the first flight in space, Yuri Gagarin, mentioned by Dr. Saviglia. The Apollo missions have been, for our generation, a really marking event that brought us close to space. ISS, you can see it with your bare eyes in the sky. But not only these very spectacular things, there's a lot that happens in our daily life that we don't even recognize. I mean, you probably know, but if you go to a taxi driver and you tell him his GPS is done by a satellite, he says, I don't care, as long as it brings me to the destination. So it's areas like communication, navigation, weather, climate, things that really have become part of our daily activities, and they're fully integrated into our life. It's also the culture that has changed due to space. We have a new picture of the Earth. I think these first images of the Earth as a sphere from Apollo 8 were quite revealing, showing the Earth as a very vulnerable planet with a very thin atmosphere, and we keep on spoiling this atmosphere. Our planetary system, we have now visited, at least with unmanned probes, all major bodies in our planetary system. And this is going on. Presently, Messenger is investigating the innermost planet Mercury, and is bringing back results which are absolutely surprising, and they change our ideas about this. The universe as such, Hubble Space Telescope, has really brought us a new view of our universe, and these 15 years of operation have made a complete revolution in astronomy. So there's a lot of things that have happened, but space is also an economic factor. We just discussed the commercial initiatives, especially from the United States. A service industry is developing using space assets. Space tourism will come up in relatively short times, so providing you opportunities to go up there, and what I would call plenty of Teflon pans, you know, the spin-offs that integrate into our daily technology. But this is really not all. I mean, this is all been achieved in these 54 years, but where and when? If you look at this map, it shows you the distribution of nations capable of launching humans in the 60s. Of course, these were the two superpowers, the United States and Russia, and the initiative for them was the Cold War. Now, it was mentioned by Dr. Saviljev that the capability of launching humans has not increased very much in the past 50 years. We have 3 nations now. China has come in addition, and actually we should crosshatch this for the moment at least to see what's going on there. If we go a step further and look at spacefaring nations, nations that are capable of launching satellites into space. So this is 9 at the moment. So that's quite a dramatic increase. And if we look at those nations that have payloads, active payloads in space, that's already 52. So here is really the strong proliferation taking place. And it was just mentioned by Dr. Saviljev that about 120 nations actually make use of space assets in one or the other way, using data, using pictures, and so on. So it is absolutely apparent that more and more nations now find the value that space can bring to their citizens, to the man on the street, as Sandile Malinga would have said. And he explained very nicely how this is done in our host country here. So what's left to do for you? Everything has been achieved, so much, so many countries are involved. So is there anything left for you? I think there is. We are presently in a transition phase. Space started with national competition. Today, space is cooperation. This is what really counts, and as you can see from the large number of countries that are involved, this is really a thing that's happening now. We also are at a time of technology turnover. We all watched the retirement of the space shuttle, some of us with tears, and this has been a very, very fascinating spacecraft. Whoever, I hope that some of you would have had an opportunity to watch a launch of this instrument. It's really very, very impressive. Now, there might be a transition. It's initiated in the United States to a commercial launch of humans into space. We don't know yet how efficient this will be. I hope that our colleagues in the United States will succeed with this. The signs that we have at the moment are very promising. And you probably noticed that NASA has just announced 2 weeks ago their new space transportation system, a heavy launch vehicle. Now, a heavy launch vehicle, of course, opens new avenues in space, and it makes new targets coming into reach for future initiatives. And I think this is where you come in. Sorry. I asked the lights to be dimmed because I knew it requires, but I have even difficulties to read it. It's your turn, that's what it says. Exploration of humans, of human activity. Exploration, the extension of human activity in space. This is really where I expect you to be active, and where you should see a field of activity where you could contribute to progress in space. Now, where could we go? Even with the heavy launch vehicle, we are limited to the vicinity of the Earth. The action radius could be defined as such. Of course, the low Earth orbit is within our reach. We've demonstrated that. ISS, the first permanent presence of humans in space, in the low Earth orbit. The Moon, again, is a target, a destination that we have demonstrated. It's close to the Earth, and we have landed humans on its surface. Possible targets are Lagrange points in the Sun-Earth system, or in the Earth-Moon system. They're very actively used for scientific satellites in the Sun-Earth system, especially, for example, for the observation of the Sun, because they're unique, stable points in this orbiting world. But the Earth-Moon Lagrangian points might play a role in the future exploration. Near-Earth asteroids are within our reach, but only part of them. It's really not the whole asteroid belt that could be that automatically will be part of our actual radius. It's a small portion of those asteroids that approach relatively close to the Earth. Then, of course, our sister planet Venus. Venus now is not so attractive. It's a bit hot there, so I don't think it will be very actively visited in near future by humans. But Mars, of course, is a very, very exciting destination, and that's, of course, part of where we would go. The ultimate destination, I think we cannot, at the moment with our technology, think beyond this. It's the ultimate destination for humans, and it's the most fascinating. And of course, the big question is there traces of present or extinct life on Mars is something that is very, very important for human culture. Now, how to get to Mars? First of all, flying directly, shooting a rocket from the Earth, flying to Mars might be possible at some stage, but it's definitively difficult, even with the new space launch system of the United States. It is intermediate stations that we need to reduce both the effort and the risk to get there. Now, we do have, of course, ISS. It's there, it's present, it's manned, and this is a suitable starting point. And as I just mentioned, the way stations towards Mars could include either the Moon or a Lagrangian point in the Moon-Earth system, or a near-Earth object, or several of those way stations to go to Mars. But whatever you do, it will always be a very long way. Now, I'm sure you're aware of this. Going beyond the moon is not just an extrapolation of what we're doing today. It's actually a very, very large step. Why? First of all, we need technology process. Propulsion techniques have to be improved. The trip is long. At the present, you have to count 5 years, and this can be a showstopper for reasons of human presence. Second, life support systems definitively have to be closed cycle. And we are approaching this, but we have not yet reached it, and it is difficult. As you are going away from the sun, solar energy gets more dilute, and it will be more difficult. You have to find new concepts for energy and also for communication. As you're going to distances where the communication delays are getting very large, you also need new concepts to communicate. So those three things sound simple, but they're extremely difficult technical steps. If you look to the humans, and this is what we're presently talking about, it's significant advances that you need. First of all, there's the question of health care. It's a completely different situation if somebody on the ISS gets sick, can go into a Soyuz capsule and will be back safely to Earth in the matter of a day. Or even going to the moon, you can return. If you're on a way out to Mars, there is no way you can interrupt your trip and have somebody back home for medical care. So you have to find ways to have efficient medical care during such a long trip. And this is still a way to go. The second point, I mentioned it already, could be a showstopper. Radiation exposure is a very critical thing, and unless we find ways to shorten the travel times and to find more efficient shielding, which is not easy, this can really be the final showstopper for people going to Mars. And finally, the psychological effect of being enclosed in a tin can with a few colleagues for a very long time and at the distance far from home with no way of returning early, that can be a very, very difficult mental problem, and this is not yet solved, and even the Mars 500 that's presently taking place in Moscow, these people are still on the Earth. It's much easier for them than being out there. So, as we learn, future exploration requires major efforts, major progress, and therefore I consider it should not be done by a single nation, it should be done by the humanity as a whole. We should involve as many as possible nations into the effort with all their capabilities and resources. But it's not only saving money and time, it really is benefits that we can take out of this cooperation. I think it's important that nations work together rather than compete. And this is good for peace on Earth. Better understanding of nations through peaceful joint efforts, as we now have it on the International Space Station. And I personally think that the cooperation, especially between the big partners, US and Russia, has definitively contributed to a better understanding of nations in the world. It's also a model for partnerships for large projects on Earth that could be a benefit from such an international cooperation. And we do have a group that is presently active and is working on this. It's called the International Space Exploration Coordination Group. This is a very efficient and useful tool for international cooperation. It's 14 space nations working, space agencies, working together. You see the logos here. They work on the principle of consensus, so they're not forcing the other into certain directions, but it's really a consensus idea. They develop long-range scenarios, roadmaps for 30, 40 years, and this helps the partners to align their programs nationally. And this is, I think, the right approach to get a coordination. And of course, the idea here is to have a stepwise and modular approach which can make the whole thing affordable and sustainable. ISAC has just published a few weeks ago the Global Exploration Roadmap. It, at the moment, still offers two pathways, and the idea is to finally come down to a single global exploration roadmap. The present roadmap contains two ways. One is called Asteroid Next, and this foresees a start on the ISS, then a deep space habitat, for example, in an Earth-Moon Lagrangian point. It would then continue to have a human exploration of a near-Earth asteroid, could, on the way to Mars, go back to the Moon, land there, and practice descent and ascent techniques for humans, and then use this to land on the Red Planet. The other approach is called Moon Next, and this means going from ISS to the lunar surface, get all the necessary technologies for planetary landing of humans there. On the way out, there could be an intermediate station again on a near-Earth asteroid, and then either continue to the surface of Mars or to one of the moons to do interactive teleoperations on the surface of Mars with the astronauts sitting on Mars moon. Now, when will this happen? Now, this question is not easy, and I think nobody can tell you when humans will reach Mars. If you look back, Wernher von Braun, 1970, created a plan to land humans on Mars in 1981. This definitively did not happen. Now, the NASA Space Exploration Initiative, this was George Bush, 1989. He made a plan intending to land on Mars in the year 2019. It's highly unlikely, I would say. Now, ESA, the European Space Agency, has created the Aurora program in the year 2001, and their goal was to reach a landing on Mars in 2030. As we go on, George W. Bush, in his vision 2004, he was proposing to go to the moon by 2020, and from there on to Mars to reach it in 2035. Now, the interesting thing from this is that apparently Mars is a moving target. When you look at this, Werner von Braun was very optimistic, and it was only about 20 years. But no, even shorter. But all the others, it seems to be something like 25, 30 years in the future, wherever you are. So it's moving with you, and we're not approaching very much. So what does ISAC say? So don't worry about this busy slide. I'll guide you through the important things. This is part of the roadmap. And what it essentially says that with the launch capabilities, heavy launch vehicle, you can go from the low Earth orbit up to the moon around 2028, 29, do some activities there, then carry on to near Earth object around 2037. But Mars doesn't even turn up here. It says future human mission. And you see, so even ISAC cannot really tell you, while developing a very well thought through roadmap, where it's going. So let me conclude by saying, first of all, I think there's plenty to do for you, for your generation, and I think it's going to be very exciting. Space exploration is a fascinating vision. In this vision, I think the most exciting target is Mars, and to go to Mars, bring humans there, and look for traces of life would be a very, very important step for humanity. Now, I hope to explain to you that this is not just steady progress from where we are now. It requires enormous technological and medical steps beyond the present state of art. It's not something that we can simply start, but it is regarded as a task of humanity as a whole. Nobody can tell you at the moment when it's happened, but you can make it happen. Thank you very much.